In today's lesson, our focus is going to be on integer exponents. Up until now, you've been working with exponents and powers that have had positive exponents, just like this power, 10 to the third power. Just to refresh, what exponents do is they elicit repeated multiplication of the base. That means that the exponent tells us how many times we multiply the base of 10 by itself to get an overall product. So if I were to evaluate this power, 10 to the third power, that means 10 times 10 times 10, 3 times. We know that 10 times 10 times 10 equals 1,000. So I'm going to show you a pattern of what happens to these powers of 10 as I move down in value of exponents, and then what happens as I get to the negative exponents. So 10 to the third power is 1,000. 10 to the second power means 10 times 10, which equals 100. 10 to the first power means just 10, and therefore the value is 10. We know from previous lessons that 10 to the 0 power, anything to the 0 power equals 1. But what happens when I go 1 less than 0 and say 10 to the negative 1? Well, I want you to consider this pattern here. What's happening multiplicatively when I move from 1,000 to 100? Then from 100 to 10. Then from 10 to 1. There is a pattern here, and you'll notice that I am dividing by 10 here. 1,000 divided by 10 equals 100. 100 divided by 10 equals 10. 10 divided by 10 equals 1. So if I continue with this pattern, 1 divided by 10, I can write that in a few ways. I could say, well, 1, that equals 1 divided by 10. What does that look like, though? And what are we familiar with? 1 divided by 10, well, this looks like a fraction, right? Haven't I said fractions are unsimplified division problems, so 1 divided by 10 can also be read as 1/10. So this is 1 divided by 10, isn't it? So the value equals 1/10. We can also write this as 1/10 can be written in decimal form as well. Okay? And so if I were to take 1/10 and I were to maintain my pattern dividing by 10 as I am getting down to a -2, 10 to the negative second power. Well, if I divide 1/10 by 10, if I divide this by 10, then what I get is 1/100th, right? So 1/100th, which also can be written as 0.01. So we have 1/10, 100th. What do you think is going to happen when I take 10 to the negative third? 10 to the negative third is dividing 10 to the negative second by 10 again, which is going to give me 1/1000th or 1/1000th. Again, if we divide by 10 here, this gives me 1/1000th. So notice the pattern. I want you to specifically notice that the exponent here does not make the value negative. It just makes it smaller. So if I have a negative exponent here, 10 to the negative third power does not give me a negative value. This is a positive value. It is a positive 1,000th. Nothing about 1,000th is negative. It's just a very small value. Keep that in mind, please. Here is your definition, or what you need to keep in mind to keep you in line with this rule, so to speak. A base raised to a negative exponent has the value of 1 divided by that base raised to the opposite of that power. So, the example 2 to the negative third means 1 divided by 2 to the third, because if we go back, has a value of 1 divided by that base, 2, raised to the opposite of that power. The opposite of negative 3 is 3. So 2 to the negative third does not make this negative. It makes it 1 divided by 2 to the third. From there, 1 divided by 2 to the third, well, 2 to the third means 2 times 2 times 2. And 2 times 2 times 2 is 8. So ultimately, 2 to the negative third equals 1/8. Okay? So here are just a few procedural examples of this in motion. 7 to the negative second power. The answer is not negative 49. That's going to be your first, your gut, your misconceptual instinct. Not true. 7 to the negative second power means 1 divided by 7 to the positive 2. This is making the value very small. It is still greater than 1. It is not less than 1. It is not negative. 1 divided by 7 to the second power. Now, you could say, well, 7 squared, 7 to the second power, 7 times itself is 49. But it's now in the denominator of a fraction, of a unit fraction even, because the top unit is 1. This is going to be equal to 1/49th. So 7 to the negative 2 is equivalent to 1/49th. 1/49th is greater than 0, not by much, but it is certainly not negative. Keep that in mind. Example B, 5 to the negative third means 1/5 to the third. 5 to the third means 5 times 5 times 5. 5 times 5 is 25, and 25 times 5 is 125. So 1/5 to the third is going to be equivalent to 1/125. 1/125th, again, this is not negative. Excuse me. C, negative 5 to the negative 2. Now this is interesting, isn't it? Because this is in parentheses, this negative 2 belongs to the whole value. So, this base, which is negative, is going to be raised to the negative 2, which means it is 1/5 to the second power. Now, still be careful here because negative 5 to the second power means negative 5 times negative 5. And what we know about integers is when we multiply and we have 2 negatives that we're multiplying, we get a positive value. So this is fabulous, and negative 5 to the negative second power comes out to be a positive value, a very small positive value, but a positive value after all. Negative 5 times negative 5 is a positive 25. So our overall evaluated solution here of negative 5 to the negative second power is 1/25th. Lastly, this example is about to, it might make you crazy. I want you to notice the difference between this example and the previous example. Notice that negative 5, the whole thing was being raised to a negative power. Here, negative 4 to the negative fourth power, the only thing being risen to the negative fourth power is the 4. Because this is not in parentheses, the negative means the opposite of. So we're talking about finding the opposite of 4 to the negative fourth power. I want you to keep that in mind and maybe put that in your notes. That when it's not in parentheses, that the meaning is the opposite of. And we'll talk about that again in a moment. So this is, and we'll put that kind of off to the side because it's still going to be the opposite of, so possibly a negative because the opposite of a positive is a negative, 4 to the negative fourth power. Now 4 to the negative fourth power means 1 over 4 to the positive fourth power. That's going to give us 1 over 4 times 4 times 4 times 4. 4 times 4 is 16. 4 times 4 is 16. So 16 times 16. Actually, if I do 16 times 4, I know that's 64. And 64 times 4, pardon me for a moment, that's 16, 256. So as I swing it around, well, let's see, 256. So we'll say that it is equivalent to, watch as I do this, this is why you can't just copy the boards. 4 times 4 times 4 times 4 is equivalent to 256. Remember that this is going to be the opposite of 1 over 256. The opposite of a positive is in fact a negative, so our answer is negative in this case, because we cannot forget that we were finding the opposite of. It is not the negative exponent that made your answer negative. It is the fact that the negative belonged in front of that 4. It did not belong to the 4, but it was telling you to find the opposite of 4 to the negative fourth power. 4 to the negative fourth power is a positive value, but the opposite of it is not. So here is a situation where you might apply this in real life. You may become a biologist. You might like working with insects. Here you go. A biologist is studying green peach aphids, which are insects. In a lab, the population doubles every week. The expression 1,000 times 2 to the W power models an initial population for 1,000 insects after W weeks of growth. Whew! So if no time has passed, 0 weeks, then W equals 0. So what we would have is 1,000 times 2 to the 0. Remember that anything raised to the 0 power has an overall value of 1, so 2 to the 0 power in this case is 1. So after 0 weeks, it's obvious that we have 1,000 aphids, because 1,000 times 1 is itself, that's our multiplicative identity, correct? So how does this have to relate to negative exponents? Well, those 1,000 aphids had to come from somewhere. They had to be born. How long did it take for us to get 1,000 aphids to even begin this experiment? So here's the kind of question you might ask. How many aphids were there 3 weeks before the study began? More or less? Think about it. Well, if W represents the initial amount, so at the beginning of the study, where we knew we had 1,000 aphids, which was 0 weeks, 3 weeks prior to that would be a -3 in this scenario. So we would still use the same expression to find the number of aphids, which would be 1,000 times 2 to the W power. So 3 weeks earlier would be represented by 1,000 times 2 to the -3. 2 to the -3 is going to equal 1 over 2 to the 3. This is not negative. It's just in the denominator now. Well, 1 divided by 2 to the 3 is 1 over 2 times 2 times 2. Because 2 to the 3rd power is 2 times itself 3 times. 2 times 2 times 2 is 8. So this is going to be 1,000 times 1/8. So then if I'm multiplying 1,000 times 1/8, that becomes 1,000 eighths. And then we can divide 1,000 by 8 to get a number of 125. Now 125 is the number of aphids I had 3 weeks prior to the beginning of the experiment. Okay? 125. Good. Oh, that's it.